Welcome to PyMath. In this problem that appeared in IIT JEE Mains 2008, it's about permutation and combination. The problem states as shown in the screen. How many different words can be formed by jumbling the letters in the word Mississippi in which no two S's are adjacent? So in this one, before we get to the problem, let's revise some of the basic concepts or formulas. For permutation type of problems where order matters, the formula is NPR equal to n factorial by n minus r factorial. So n is the total number of objects that you got, or total number of choice that you got, and r, keep it as if like you're going to be filling up r spaces or r spots. So this is the total number of choices that you got. R is what you are going to finally be using for, or spots to fill, or places to fill, right? So that's the NPR formula. For combination type problems where order does not matter. So let's say in this problem, we got multiple S's here, multiple I's, and multiple P's. So among themselves, there is no difference. They're all the same alphabet. So in scenarios like that, the order doesn't matter how you arrange them between themselves. So that's where the combination formula would come into play, which is NCR, n factorial, divided by n minus r factorial, r factorial. N is again total number of choices that you got. R is what you're going to be filling up or using. So this is the bigger set that you got that you can use, and R is a subset that you're going to be actually using or filling up. So remember these two formulas, and let's get to the problem. So before we solve the problem, let's write down the word that is given. M-I-S-S-I-S-S-I-P-P-I. Let's count number of alphabet that we got in this word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 alphabets are there. So we're going to be dealing with yes separately because you cannot have two S's beside each other, so they have to be separated out. So we will deal with S separately. We will write down everything else right now. M, I, P, P, I. So we are talking about 1, 2, 3, 4, 5, 6, 7 alphabets. So in this one, there are 4 I's, right? And 2 P's. So among themselves, there is no difference. So how many different ways that 7 alphabets can be arranged is 7 factorial. Because for the first space that you're going to fill, you will have 7 choices, and second space you got 6 choices, and third one you got 5 choices, blah blah blah, and the last one you'll have only 1 left. So that's where the 7 factorial comes into play. But there is only one catch here, because the I's and P's in this set of alphabets, among themselves, they don't have to be differentiated. So that's why you can divide this by 4 factorial for the I, because there are 4 I's there, and 2 factorial because there are 2 P's there. So that's what you got for total number of arrangements for the rest of the words. So now let's deal with yes. So as I said, we are going to be dealing with yes here. So yes should not be beside each other. So we got 1, 2, 3, 4, 5, 6, 7, 8 spots that we can use. And we got 4 options there. So again, think about it. So here we are thinking in reverse. So we got 8 spots to fill, but we can use only 4. So again, it's a combination. So, and the order doesn't matter between the S's that we got. So we got 4 S's. That's why it's 8C4. So looking at the options that are given, A, B, C, and D, they are not exactly the same as what we arrived at so far. So let's try to have a closer look. So there are 2 8C4s, there are 2 with 7C4s, and so forth. So let's see whether we can see anything similar to 7 factorial by 4 factorial, 2 factorial. So if you separate 7 factorial as 7 into 6 factorial, so you will have 6 factorial, and this more or less looks like 6C4, which would be like 6 by 4 factorial, in bracket again 4 minus 2 factorial, which will be 2 factorial. So that's what it looks like. So is there anything with 6 multiplied by 7C4? Yes, we got 6. So we got 7 multiplied by 6C4. We got it there. So we can separate the 7 factorial as 7 into 6 factorial divided by, the rest of it is 4 factorial, 2 factorial multiplied by 8C4. We are going to keep this one as it is, but we are going to be separating this 7 factorial by 4 factorial, 2 factorial as 7 multiplied by 6 factorial divided by 4 factorial and a 2 factorial. So have a close look at this one. This is same as 6C4. So 7 multiplied by 6C4 multiplied by 8C4, which is the D that is given there in the number of options, and this is going to be the option D. So this is what you should do in this kind of problem. First, see whether permutation or combination applies, and see how many items that you're arranging, and see how many are duplicates. And when you're filling up spots after you are done with jumbling, think about how many spaces that you got, how many objects that you got to fill. So that's how you arrived at the 8C4, and then play with the factorials, separate the factorials out to simplify if you can, to match with the options that are given in the problem. So that's the way to solve these problems. Hope you enjoyed the video. Thanks for watching.